Hi and welcome to Geeks for Geeks. Can I have a quick +1 in the chat if I am visible as well as equally audible? Then we would start right away. +1 in the chat. Okay. Okay. Thanks a lot, Shruti. Yes. Thanks a lot, Think Positive. Thanks a lot, Ankita Kumari. Okay. So today, let's start. 5 people have already joined. Okay. So today we would be discussing yesterday's problem of the day, that is maximum rectangular area in a histogram. Okay. This question came in Microsoft, this question came in Google, and this has a success percentage of 47%, and this is a medium level problem. Okay. So now, Ashish, thanks a lot. Thanks a lot. Hey Pankhodi. Okay, so let us understand the problem statement now. In the problem statement, you would be given the height of each bar, okay, and the breadth would be just 1 unit, okay. Every breadth would be 1 unit of each bar. Good enough. Now you need to find the largest rectangular area possible in the given histogram. Okay, you would be given, suppose 6 2 5 4 5 1 6. So 6 this side, 2 1 this side, 5 4 5 1 and 6. Okay, and you need to report the largest rectangular area possible. Okay, now in this question it means that suppose you have length like this and you have a length like this and you have length like this. So the thing is that this would account into the rectangular area. Okay, or this would account, or this would account, or only this would account. If you want all the threes, then this would account. Okay, there can't be any gap, in short. Okay, now I think you have understood this. Now taking into account, now let us see the largest, okay, possible area. So we can see that we can go from here to here to here to here. Okay, good enough. Now what is the area till this point? Area till this point is 1 2 3 4 and 5. So 5 into 2, that is 10. Okay, so for now the answer is 10. Okay, now let us see for the next one. Okay, now for 5, how far we can go? We can go no far, but only 5 into 1 is equals to 5. So that won't be contributing to the answer. Now for how far we can go? We can only go till this far. Okay, and this would be 4 into 3, that is 12. So 12 is greater, so the answer would be 12 for now. Okay, now moving forward, then 5, how far we can go with the height 5? We can't go anywhere further than only this. So 5 in 5 ones are 5, that is 5 only, so this won't contribute to the answer. 1 into 1 is 1, so that would also not contribute. 6 into 1 is also not applicable, 6. So 12 is our answer. This is how. So we can see, okay, we can see that we need to travel. Okay, we need to consider each bar. Okay, each bar, and we need to see how far we can go. How far? What do you mean by how far? How far we can go means that assuming the height as 6, how far I can go. Okay, how far I can go with the minimum height as 6. Okay, if I go just here, the minimum height becomes 2, so this is not valuable, this is not valid. Okay, if I go this side, there is no bar, so only one bar is remaining, so 6 into 1. Okay, yeah, good enough, Siddharth. Now moving forward, suppose we have the height 2. Okay, so if I consider 2 as the minimum height, how far I can go? I need to say this. So I can go for 1, then 2, then 3. After that the height becomes 1, which is less than 2. So the minimum would now be taken over by 1. So I won't go that side. Now moving this side, so I can only go one direction. So 1, 2, 3, 4 and 5. This is how far, this is to see. Now talking about this, same would happen on the 4 itself. Okay, we need to see how far we can go with the minimum as 4. Okay, we need to go this side and we need to go this side. This is it. So now we can see, we need to get the index of the element which is nearest and smaller. Nearest, next smaller element. Nearest, next smaller. Okay, nearest next smaller means that suppose this is 4, so 5 is greater, so this won't account. Then 1 is less than 4, so this would account. Now moving this side, how far we can go? 5 won't contribute and 2 is less than 4, so we can say that. Okay, so now we need to find the nearest smaller element. Okay, so now the thing is that how to calculate the nearest smaller element. But before doing that, can I have a quick yes or no from you that how we need to calculate the nearest smaller element? Can you say this or not? You just need to visualize this example, and in the first sample test case only you would be able to say that you need the next smaller element. Not have a, can I have a quick yes or no that you have understood that where from we are coming to the conclusion that we need the next smaller element. Okay, okay. Now how would we calculate the next smaller element? The next smaller element, okay, so we can see that suppose we have 5, 6, 7 and 8, and then we have 9. So we can see that the element, the next greater, okay, just see this, okay, sorry, 5, 6, 7, 8 and this would be suppose 1. So we can see that we need to go till we have a element greater. This is also greater. 6, 7 is also greater than 6. 8 is also greater than 7. And when we found an element which is less than this, we can say that 1 is the next smaller element of all this. Okay. Now suppose the element is just like this. 7, 8 and 9. This is just 6. So what we can say that this is greater than 5. This is greater than 8, this is greater than 9. Okay, then we encountered 7. So we can say the numbers which are greater than 6, okay, and are already there are the next greater element of 6. Okay, next smaller element is 6. So we can say that these all elements, next smaller element is this, and this element's next smaller element is nothing. Okay, now how would we do that? We would do that by simply using a data structure known as stack. Okay, how we would do that? We would initialize a stack at the moment. Okay, just a sec. Hello. Okay, so now we need to see. Okay, so now we need to build up a stack itself. Okay, so let's build a stack here. Okay, good enough. So now what we would do is we would first keep 6 here. Okay, just let me, yeah, first let us keep 6 here. So 6, there is no element in the stack. If there is no element, we need to push the element. Okay, so no element, we would just push this element. Now we found, now the next element is 2. So we can see that 2 is smaller than the top element. So what we would do is we would keep popping the elements while the stack is not empty and the top element is greater than the current element. Yeah, 6 is greater than the current element. Okay, so what we would do is we would say 6 next smaller element is 2. Okay, and after this is done, we would remove this 6 and we would insert this 2. Okay, then we would move to 5. Okay, now we can see that 5 is greater than the top element, so we won't do anything, we would just push it. Okay, then we have 4. So 4 is smaller than the top element. What we would do is we would pop out this 5 and say that 5's next smaller element is 4. Okay, now we would again, what we would do is, after this is done, now again we have a smaller element, okay, then we would just insert this 4, okay. Now the next element is 5, okay. Now we can see that the top element is smaller than that, so we would again insert this 5, okay. Now the current element is 1, okay, so we found an element smaller than that. What we would do is, we would simply keep popping this, like we would say that 5's next smaller element is 4, 1, and 4's next smaller element is 1, and 2's next smaller element is 1, because all these elements are smaller than 1, okay, larger than 1, okay. Now at the end we would just push this, okay. Then we found an element which is greater than the top element, we would again insert this. At the end, whatever is remaining, we would pop all these elements and say that they don't have a next smaller element, okay. So 6 don't have a next smaller element, so we would just write no, and 1, no's next smaller element, we would just write no. Now the problem here is, we can't figure out that which 5 is this, and the ordering is not maintained. We can see that in this 6 is first, yeah, 6 is first, but 2 is second, but we don't know 2, we are coming across 5, so we are coming across this 5, then directly after this 5, okay, and we won't be able to differentiate which 5 is this, okay, because for 1 5, the element is 4, next smaller element is 4, and for 1 5 the next smaller element is 1, so we won't be able to figure it out, okay. So now what we would do is, we would simply, instead of these all elements, we would simply push the indexes now, okay, so that we have the proper, okay, we have the proper values, okay. Now we would mark the indexes 0, 1, 2, 3, 4, 5 and 6. Good enough. Now what we would do is, we would make another array, okay, another array like this, okay, 1, 2, 3, 4, 5 and 6. 1, 2, 3, 4, 5, 6, okay, whatever be the thing, okay. Now we would just mark the indexes like we did here, 0, 1, 2, 3, 4, 5 and 6, okay. Now the thing is that this 6, instead of passing this 6, we would pass the index. The array is empty, okay, so we would pass on the index here, so we would pass on 0 here, okay. Am I clear till now or not? Am I clear with taking out the next smaller element or not? Okay, nearest next smaller element, okay, next smaller element, am I clear or not? Just let me know, okay. Okay, after that we have the second element, so 2 is less than 6, so what we would do is, we would simply pop out this element, and we got the index, okay, we would got the index, and we would touch this 0th index, and we would write 1 here, the current index which we are at, the position, okay. So this is done, and we would insert 1, okay, 1, and it would tell me which element itself. Good enough, okay. Then we would come on to 5, okay. Now 5 is greater than, so we would just write 2 and 5, okay. Then 3 and 4, so 4 is smaller than 5, so what we would do is, we would pop out, and we would pop out to the index 2, we would go to the index 2, and we would write the index 3 here, okay. It is done, and the next element is larger, okay, so 3, and then this element, whatever be this. So the idea is that we would just be passing the indexes, and we would be filling up the array, okay. Now this talks about the next smaller element on the right hand side, but the thing is that we need to look on the right hand side as well as on the left hand side. We need to look at both the conditions. Now to look at both the ways, what we can do is, we have talked about this one is done. What we would do for this case is that we would simply iterate from the back itself, okay. We would iterate from this position, and we would do the same thing, but just the for loop would be changed, okay. Just the for loop would be reversed. We would be moving from n-1 to 0. Here we were moving from 0 to n-1. Do you need the dry run? Okay, do you need the dry run, or I should move on with the other things. Okay, now talking about the next thing, what is the implementation idea is that, okay, now talking about the next thing, just let me know if you want the dry run for the next smaller element on the left side too, or this is okay, we can move forward. Just let me know, do you want or not, just yes or no. Okay, if you want, just let me know, or else just say no. Okay, so I would know. Okay, now we need to see. Okay, now the thing is that suppose this is 6. Okay, so next smaller element on the right hand side is 2, this one, but the next smaller element on the left side, there is nothing. There is nothing known as next smaller element on this side. So what would we do in that case? What would we do? So we would do nothing, but what we would do is, while we would just mark here -1, okay, and we would mark here n. Okay, so how the value would be like this, the value marking would be like this. Okay, so the marking would be like this would be -1, this would be 0, this would be 1, 2, 3, 4, 5, 6, and this would be the 7th. Okay, so the idea is that suppose we have the current element as 6. Okay, so next smaller element on the right hand side, there is nothing. So what we would load in that is, we would just load 7 here. Okay, so for the sixth index we have 7 here. Okay, dry run is needed. Okay, dry run needed. Okay, absolutely. Okay, so now let us talk about this idea only, initializing with -1 and 0 with this. Okay, left hand side. Okay, left hand side. So we would start moving from this side to this side. Okay, this side to this side. Okay, now this is 0th index, this is 1, this is 2, this is 3, 4, 5 and 6. Okay, so now what we would do is, we would pass, if the array is empty, we can't do anything, we don't have anything to compare, we would simply insert this. Okay, 0. Okay, and just to keep the values, I am just storing in bracket. We would just store the indexes only, but for understanding here, we would just store the value it is containing. Okay, so 0 would contain 6 here, just the value, the bracket one won't be implemented. Okay, now the stack is empty. Now we have the next smaller element as 1 and 1. This is the current element. So what we would need to do is, we need to check, okay, if there is an element which is greater than that or not. Yeah, there is an element which is greater than that, that is 6. So what we would report is, we have the array as something like this. Okay, 1, 2, 3, 4, 5, 6, 7. Okay, so just mark the indexes 0, 0, 1, 2, 3, 4, 5, 6 and 7. Okay, so what we would do is, we now know that 6 next smaller element on the right hand side is 1. So we would just write 1 here. Okay, we would just write 1 here, and we would pop out this 6. Okay, and then we would insert 1 in the bracket, the element is also 1. Okay, so now the next thing what we would do is, we would again pass this 5. Okay, we would again pass this 5. So 5 is greater than the last element, so we would just push it. Okay, so 2 and then 5. Okay, and the indexing is done from back itself. Why? Just for the sake of understanding, indexing is done from the front itself. Okay, now the next thing is that 4, we got an element 4. 5 is greater, okay, than 4. What we would do is, we would pop this. Okay, and we would mark the element of 2. Okay, we would mark this one. Okay, just this thing, let me change the indexing. 0, 1, 2, 3, 4, 5, 6. Let's not ruin this. Okay, okay, till now 6 is complete. So we have the element, the index 5 with the element 1. Then we came across this element, the index 4 with the element as 5. Okay, so 5 is greater than 1, so we would just mark this index with the element 5 itself. That is also greater. Then we came across 4, which is less than the top element. What we would do is we would pop this element. Okay, but before popping, we would mark that the next smaller element is the current element. What is the current element index? That is 3, and we would pop this. Okay, then we would insert index 3 with the element as 4. Okay, then we came across 5, which is greater than the top element. So what we would do, we would push this. Okay, and the value in brackets. Okay, just for the sake of understanding. Then we have 2 here. So 2 is less than 5 and 4. So we would just go to index 2 and we would mark here. 1. Then index 3 we would mark here 1, and we would pop both these two. Okay, we would pop both these two. Okay, and we would insert the index 1 with the value in brackets. Okay, then we come across 6. This is how we would be filling up the array. Okay, this is how. Now moving forward with this, now what we would do is the elements which would be remaining, the next smaller element, there is nothing, so we would mark this only. Okay, the n value. Okay, now let us move to the implementation. Now first we would calculate the next smaller element on the right hand side. We would initialize a stack with long. Okay, now right side array and the left side array. If the stack is empty, we can't do anything, we would just push the indexes. If the stack is not empty and the element which is already inside is greater than the current element, we would just mark the index and then pop it. Just mark the index and then pop it. And this would go till this is true. At the end, we would just insert. Okay, and whatever elements are remaining, we would just mark the elements as the last value. Okay, and then we would mark this side also. We would do the same thing, just the iteration would be n minus 1 to 0 and the value would be minus 1. Okay, now suppose I know all the indexes 0, 1, 2, 3, 4 and 5 and 6. Okay, now suppose I know that. After a little bit of observation, if I am at the current index 3, so the next smaller element's index is 5. So it is 5, and then the next smaller element on the left hand side is 2. So 5 minus 2 is equals to 3, the current element. Okay, this would give me the breadth of it. This is how we would be doing it. Okay, so now let us move. So what we would do after that is we would just mark Ri minus Li. Okay, we would do, because Ri would always be greater than Li. So Ri minus Li minus 1 multiplied with the breadth itself. Okay, the value at the current position, and then we would be keeping that in the answer. At the end we would be returning it. Okay, now there is one more disclaimer or a note here. Okay, now the thing is that n's value is still 10 to the power 6. Okay, n's value is 10 to the power 6. So if you initialize an array of 10 to the power 6, you would get a segmentation error. Okay, and many users got that, including me. Okay, so in that case you need to use vector. Okay, and if you use a vector, you would be getting the AC if you use this logic only. Okay, and now and getting the maintaining the order in next smaller element, there are other ways too, like you can do hashing, you can push the values as a pair of int and int in stack, but I found this as the most simple one, because we just need to push the indexes and everything would be damn good. Okay, just take care of this thing. Okay, we would compare not the stack.top but array of stack.top. This is very important. Okay, now I would be waiting for the next 1 minute. If I don't get any doubt, I would be turning this session off. Now let me know if this is clear or not. Okay, just let me know if this is clear or not. Now, summing up the things, what we needed to do is we found the next smaller element and the next smaller element. Why? Because it would tell us that the current element is minimum till how far. This would be the idea. So we would take out the next smaller element and next smaller element. Okay, and now we would just subtract these values and multiply it with the current value, and the maximum of these all values would be our answer. Now, one thing is that suppose the next smaller element, there is no next smaller element on the right hand side. So what I did was, instead of that, I stored there n, okay, just the next one, okay, because the thing is that suppose there is 6 standing at the last position, so we can see that it can go for only till this point, so we just went to n itself. Okay, thanks a lot Shruti, thanks a lot Mankhori. Okay, so I hope everything is clear now. If you still have any doubts, then you can connect with me on LinkedIn or leave a comment here only. Okay, that's all for today. Thank you and have a nice day.